Okay, so yesterday we did a regular exponents booklet to start to kind of review. Today we're going to do a little more intense one, okay? We're going to do a little more negative exponents. So you've done these before, you've done even this booklet before, but let's just go ahead and go through a little bit of it. We shouldn't have any issues with this one. We're multiplying, okay? Um, this one is a subtraction. Who wins the battle? The top. The top by 5, right? The 2 takes away 2 of these, so that's 8 to the 5th. All right, for this one, so we're going to talk about this one together. If you were to multiply this, if you remember, you're going to multiply these two numbers, right? So you're going to get 7 to the negative 8. But if you recall, this has to change, right? You can't have a negative exponent. Do you remember what to do? You are never allowed to have a negative exponent. It has to turn and flip sides and go to the bottom. Look at my answer there. Remember, it has to flip sides, okay? So that's what we got to make sure remember. A negative exponent cannot stay negative. It has to flip and go to the other side, whatever side it's on, okay? Let's keep it going. Let's see. That shouldn't be an issue. This shouldn't be an issue. Okay, let's just talk about this one actually. What are you supposed to do with this one? I want you to add all these. Why are we allowed to do that? Because they're all threes. They all have the same base. They have the same base, but different exponents here that when you're multiplying with the same base, so you get to add all across. All right. Well, negative 2 and 4, this is going to be positive 2. And then the 5 comes into play. That's going to equal plus 5. That's going to equal 7. All right. Then you have 7 here and bring down this negative 8. 7 and negative 8 actually becomes negative 1. So it becomes 3 to the negative 1. But if that answer is not there, it has to turn and flip over. It could have the 1 there or it couldn't. All right. Either way. And that could be your answer. All right. So take a look at that. That was a lot. That was a lot to look at. Let's see what our answer here was, though. 1 over 3. That's intense. 1 over 3 was your answer there. All right. Oh, snap. All right. We're getting into some intense stuff here. Pay attention. All right. Looking at this problem, we cannot have this here. Remember, it has to flip and go down. What happens when it flips and goes down? It becomes positive. Okay. So how many are on the bottom now? Pay attention. All right. And then what's on the top? A 1. All right, so 1 over x to the 9th. All right, so that's your answer. That's a little more intense, okay? All right, what about this guy? What would go here to make this true? Oops. What would go here to make this plus this equal this? 4 plus, what is it? 8? Does that make sense? Would that make sense? 9 to the 8th? So this is the number you're looking for. 8 would make this sentence true. This is super important to understand. You may see this again on your benchmark, all right? Now, keep going through this. We just talked about that one earlier, 4 to the negative 8, but it has to be 1 over 4 to the 8th. All right, what about this guy? Seeing this one here, it can't stay negative. It has to go to the top and become positive. Okay, all right. Make sure you understand what's going on here. And other than that, okay, this one's a little more tough. You got to move this up here, but some people think, oh, this is just going to cancel out. No, it's not. It's not. This is going to move up top here. Let me clear this again. Move up top and become 3 to the 5th. It has to turn positive, remember? It has to turn positive. And when it does that, it goes to the top. It becomes 3 to the 10th. Okay? Other than that, I want you guys to do the best you can on this, okay? This one moves to the top. This one's a little more intense, but this moves to the top. So your answer would just be a squared. That's it. And goes to the bottom. We did that one already, and we did that one already. All right, best you can on this. Now that you're done, get your sheet in front of you with a pencil. We're going to do a little bit of notes here with this new concept we're going to learn. All right, let's change this real quick. Oh, how about I plug it in, Marissa? Oh, no, it's good. We should be plugged in. All right, what's going on here? Come on. Sorry, guys. 1 second. Okay, this sheet in front of you, we're going to go through this right now. So as you look through this, let's make sure we know what's going on. This is called scientific notation, and this is what they do. They use this notation to tell you about really, really big numbers, and sometimes it deals with space. All right, this is my solar system, maybe. That's my sun. It talks about the numbers in space. This is the rings around Saturn. That's what I was trying to draw here. If I drew a sphere, all right, this is the world. And then these are like little meteors. I'm getting crazy here. But if they were trying to tell you how big the Earth is, the number is so large that they take it into different kind of way of looking at it where it looks like this. So look at this number down here or this number down here. This is a different way of looking at how these numbers are written. And this is called scientific notation. All right. Now, this is written in scientific notation, but they're going to tell you they want it in standard notation. Standard is normal. Like this is all standard notation. All right. We'll go all about it. Don't even worry. Write each number as a power of 10. All right. So you're going to write this out. You can write one, actually, if I wrote this out, let's make sure we understand. This would be 10 to the second power. Do you get that? 10 times 10, right? And there's also a little bit of a trick here. How many zeros are there as well? Sometimes that'll help you. This will be 10 to the 1, 2, 3, 4th power. All right, 10 to the 1, 2, 3, 4, 5, 5th power. Okay? All right, 10 to the 1, 2, 3, 4, 5, 6, 7th power. Okay, keep going. Why don't you fill this out? 10 to the 6th, 10 to the 4th, 9th. Now, what about this one? This isn't any power to 10, right? So we'll talk more about this one in a second. Don't worry about this one now. I don't want to get you confused, okay? Now, if I did have to talk about it, we'll talk about this later. We'll revisit it. Don't worry. So now write this in standard notation. How would you write this out? 10 to the 3rd. How would you write it out? How many zeros? 3? All right. Okay. 5. How many zeros? For this one, it's just 10 to the 1, right? Isn't that what it would look like? 10 to the 6. 2, 3, 4, 5, 6. 10 to the second. Uh-oh. This is what this one was talking about. Remember? Anything to the 0 power becomes 1. So this would have been 10 to the 0 power. Okay? But I didn't want to mess with you right away on that. Remember, 10 to the 0 equals 1. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7. Okay? All right, now this is a new concept, so I want you to see what's happening. This is all going to be very interesting the way we do this, but I want you to understand the first and most important part of writing this out. We're going to write this out. These numbers are going to be written like these, okay? The way these are written, times 10 to the something. Everything's times 10. It's all on bases of 10, okay? So we're going to write this with bases of 10, so let me tell you what's happening. Are you ready? We're going to go ahead and, first of all, do you notice that this has a decimal? These all have, and you can't see the decimal there, but there's a decimal there. Decimal. No decimal there, no decimal there, but there's a decimal here, here, and here. And if I ask you one question with all these decimals, where do you notice the decimal is always placed? The decimal is always after the first number, okay? The decimal is always after the first number. So we're going to do that here. We're going to put our decimal right there, 2.5. All right, just stay with me. If you're kind of lost, it's okay. But 2.5, and it's going to be times 10. We get to do it this way. We can just put the numbers. We don't have to put all the zeros because we can include the zeros with this. Now, how many spaces? I'm running out of room with this marker. It's kind of showing me out. How many spaces was this going to be? 1, 2, 3. So it becomes 2.5 times 10 to the third. Okay? 2.5 times 10 to the third. And if I wanted to write this out as a normal number, I would write 2.5, and then I would go 3 spots. 1, 2, 3, and I would move the decimal spot right there, and that would get me back to where we started. Okay? Kind of confusing. Don't worry if you're a little lost right now. I get it. Where does the decimal go here? 3.0. You can just put 3 times 10 to the how many spots? 1, 2. Okay? Where does the decimal go on this one? Right after the first number, and include all the numbers besides 0. You should include all the numbers other than 0. Okay? 4.73. times 10 to the 1, 2, 3, 4. All right, I went 4 spots. Where does the decimal go here? Always after the first number. And if the decimal's here, how many spots do I have to go? 1 spot. So times 10 to the 1. I know it's confusing. I know. We're going to deal with it. This one, you do have to put your decimal after the first number, and you do have to include all of that nonsense. 4, 5, 6, 5, 4, 5, 6, 5 times 10. If my decimal is here, I go 1 spot, 2, 3, 4. Okay. Where does the decimal go here? Right there. 7 point, how many spots? 1, 2, 3. This one's kind of weird. It wants you to include all non-zero numbers, but you're like, those are zeros. But since there's a number at the end, you have to include it all. Don't worry too much about that one. We're not going to see that again. All right, what about this one? 1.905. We'll start right here. 1, 2, 3. Okay. 4, 5, 6, 7. Times 10 to the 7. 3.3 times 10 to the 1. All right. Now we're going to go backwards, and we're going to write these out in normal notation. How many spots am I going to go? 6, and the decimal's there. 1, 2, 3, and you fill them in with zeros. Okay? 4.5. You go 1, 2, and you fill it with zeros. So 450. 7. Oh, this is annoying. There's going to be 7 spots. 1, 2, 3, 4, 5, 6, 7. All right? So it's like 70 million. All right? See how big that number is? 1.05. But how many spots am I going to go? 4. 1, 2, 3, 4. All right? 10,500. Oops. What about this last one? 3.05, we're going to go 1, 2, 3, so it's just going to be 3,052. 5 times 10 to the 1, or 0, everything turns into 1. Remember? All right, 9.87 is going to be 9 point, you're going to move it over, it's going to be 9.8, you're going to move it over 1 spot. So it's actually going to be 98.7. That's kind of weird, but it moved over 1 spot. 5.43, you're going to move it over 1 spot, it's going to be 54.3. All right. Now, the average distance on the moon from the Earth is about 384,400, okay? Kilometers. Write this number in scientific notation. No problem. Let's go ahead and do this. We're going to go ahead and write it. Where do we start it? 3 point. Doesn't the decimal go there? 844. We have to include all the non-zeros in there. All right. And then times 10 to the 1, 2, 3, 4, 5. Okay. And then the radius of the Earth is 6.38. We're going to go 6.38. And how many spots are we supposed to go? 3. 1, 2, 3. And there's your decimal. It moved over. All right. And that's going to be 6,000. Oops. 380. Okay. It's confusing. I get it. Don't worry. We're going to go over this again. I want you to try quizzes, and then I'm going to give you a booklet, okay, for today. Do the best you can with these. You guys are great. I know you're going to be fine at this. Tomorrow, don't lose this paper. Tomorrow, we're going to cover it when it gets small numbers. These are really big numbers eventually, like this became a really big number. We're going to talk about it when it's smaller numbers,